I'm on page 3. Not differentiable. Not differentiable. Here's an obvious one. If a function is not continuous, the function cannot be differentiable. So what does this mean? Again, it's a limit. So the limit from the left of 0 of the difference quotient has to equal the limit from the right of 0 of the difference quotient. If one limit is 5 and the other one is 10, if the limit on the left is 5 and the limit from the right is 10, this function does not exist. Therefore, this function is not differentiable. So the limit of the difference quotient on this side is this slope. The limit of the difference quotient on this side is this slope. Not differentiable, since it is not continuous. So a function is differentiable at a point if the limit of the difference quotient on the right and the limit of the difference quotient from the left are the same. In other words, there is a unique tangent there. So here's a second situation. At this point, which is a corner, the function is not differentiable. How come? Because at this point, it does not have a unique tangent. This is a positive tangent. This is a negative tangent. So at this point, the function has a corner. It's not differentiable. The derivative will not be continuous. So the derivative has to be continuous. It will not be continuous. Here the derivative is continuous. Okay, at a corner. Another situation, what we like to call cusp. Like between two teeth. So, vertical tangent. Another one, exactly just that. So here it is, x cubed. I'm sorry, the cube root of x, I meant to say. The cube root of x has a vertical tangent here. What does the vertical tangent mean? The limit is infinity, or negative infinity, or d and e. So these are the situations in which a function is not differentiable. So very important concept, continuity implies differentiability, or the other way around, none of the above or both. Who would like to give it a shot? I cannot ask you questions if we haven't discussed the topic. So now it's up to you. Which one, who would like to give it a shot? Continuity implies differentiability, differentiability implies continuity. Both are true. One is true, none of the above.
Whatever it is, differentiability, it will make sure that it is continuous, but just because a function is continuous does not mean it's differentiable.
Thank you, Derek. Thank you. Yes, this one is not true. This one is always true. This is a continuous function, but it's not differentiable everywhere. This is a continuous function, is not differentiable everywhere. This is a continuous function, is not differentiable everywhere. But if the function is differentiable, It must be continuous, guaranteed. Because if it's not continuous, it's not differentiable. So if a function is differentiable, it must be continuous. The converse is not true.
I got a question.
Please.
What about with like a function that's only valid in like one direction, like the it starts at 0 and then goes to infinity from the domain?
So you're talking about the square root of x, for example?
Yes. Since it's not continuous through the domain, it's doesn't have a derivative?
But the square root of x is continuous. So this will, the derivative of this will exist everywhere except at 0, because it has a vertical tangent here.
So it doesn't necessarily have to keep going off into infinity?
No.
Okay.
Not necessarily. As long as it has a unique tangent, if the tangent is unique, it will be differentiable everywhere. And if it does not have a vertical tangent. So here it has two tangents, here it has a vertical tangent. If it has only one tangent always and never a vertical tangent, then it's not, that's two tangents anyway. Then the function is differentiable everywhere except when it has two tangents or vertical tangent, or it's not continuous. Okay, should be our next step. We're going to start with this. It's a perfect ease into what I was trying to do next anyway. So you just made it easier for me. So we are asked here to find the derivative function of f of x equals the square root of x. Now I'm asking you to give me the starting point. How do I determine that? What do I have to write? Carson, would you like to tell us how we start this?
Would you start with the limit as h approaches 0?
Excellent. Limit as h approaches 0. Leonardo, what do I write next?
I'm not sure.
Okay, Nabiha?
I'm not sure either.
Jordan?
I should plug in h plus 8.
You always do that to me. Okay, how do I differentiate Jordan with an A and Jordan with a Y? Teach me the pronunciation, please.
Mine's Jordan. I mean,
Okay.
unless say like Jordan C. I don't know the other person's last name.
Okay, so I'm gonna say JC. From moving on, you are my JC. Is that okay with you?
That works for me.
Okay. So Jordan, not JC.
Yes.
Yes, how do I continue?
Would it be the square root of x plus h?
Great job, of course.
Minus the square root of...
Right, it's a difference quotient. We talked about that for a month already. Good. Okay, what is the next step now? We're trying to find this limit. Javon, what do you think? What is our next step here?
Don't you have to multiply it?
Excellent. By what? Yes. Yes?
Would it be I'm not sure. I know you have to multiply it though.
Multiply by the conjugate?
Thank you very much. The square root of x plus h, that was 10?
Yes.
Good. Next, ooh, look what I did. A mug of water. Sorry. Okay, moving on. Can anyone give us the numerator? Gia, the numerator.
Would the square root of x's like cancel out?
The numerator, please.
So yeah, I'm saying, would the square root of x's, would they cancel or no?
So just tell me what to write.
Okay, so I guess you could write 2x. No, it'll be x to the second. 'Cause the square roots would cancel out on the top.
So what do I write?
X to the second. Well, it's not it. Plus h to the second.
So x plus h minus x.
Very good. So we are using the formula a plus b times a minus b to get a squared minus b squared. A squared minus b squared. Good. Next step. I'm going to do the easy part. So then limit h approaches 0. H in the numerator. H. The square root of x plus h plus the square root of x. Can anyone tell us what to do next? Trey? Trey, are you with us? Okay.
Cancel the h's.
Of course. Very good. And now can anyone give us the final answer? Oscar, what is the final answer?
1 over square root of x plus h plus the square root of x.
One over the square root of x.
Sarah?
I mean,
Okay, JC, what did you say? I just dropped the limit operator, so what is the answer?
yeah, I'm plugging in 0, sorry. It'd be 1 over square root of x plus x. Square root of x plus square root of x, which would just be... Yeah, I'm not sure. I just know you plug in 0.
Okay, well, how much is an apple plus an apple?
Would it be 2 square root x?
Very good. Thank you. This is the derivative function to be carved in stone in our brains moving forward. Forever. Can anyone tell us where is the square root of x not differentiable? And why?
Would it?
Sorry, unmute
Is it
your...
at 0?
Exactly. Why?
Because there can't be a 0 in the denominator.
That's it. So the derivative does not exist at 0, therefore the function itself is not differentiable at 0. Very good. So this is our first derivative function. So now let's go to and share our, I'm going to share my screen. Where is my, I got it, I'm already there. Let's choose another function and then move on. I'm sharing my screen. My ebook. Come on, come on, come on. Okay, so let's go to the ebook. And section, this is section 2.8. So let's click on 2.8 and choose whatever other function you would like to see its derivative. Calculate it. Any function you want. I'll tell you where. 2.8. Here it is. We're going to look at other problems in a minute, but I would like us, since we... Does this happen to you? It takes you back when you... Or maybe I'm going too fast. Sorry, guys. Okay.
No, it does the same thing. Don't worry.
Okay, thank you. Find the derivative of the function using the definition of the derivative. This is what we're looking at. State the domain of the function, domain of its derivative. So please choose anything you'd like. We already
32.
32. Where is it? Okay, very good. So let's look at 32 and then we continue. So g of x is 1 over 1 plus the square root of x. I would have preferred not to do the square root of x again, but that's fine. We picked that. Let's work on it. Good. So can anyone give us the beginning? So this is g prime equals. Nabiha, will you give it a shot again?
Yeah, it would be, 1 second. The square root of 4, or...
Sarah?
Yeah, square root of...
Sarah? Will you give it a shot?
Yeah.
Yes.
Would it be 1 over 1 plus the square root of x, or limit as h approaches 0?
Ah. Yes.
And then 1 over 1 plus the square root of x plus h?
Very good. Minus 1 over the square root of x divided by h. Is the difference quotient, we said that, that's the limit of the difference quotient. Good. Okay, so now we plug it in. I should have said that from the very beginning here. When you plug it in, you get 0 over 0, of course. So when you plug h approaches 0, the numerator is the square root of x minus the square root of x, which is 0. The denominator is 0, 0 over 0. So there is hope. And we did find something. Good. So next step. So what do we do next? So limit as h approaches 0. So at this point, if we plug it in, we're going to get 0 over 0, of course. There is no discussion there. When you plug in 0, you have, oh, I'm sorry, 1 plus here. So when you plug in 0, then you get 1 over 1 plus the square root of x, minus 1 over 1 plus the square root of x is 0 over 0, clearly 0 over 0. So at this point, we have to find the least common denominator. That's our first step. Can anyone give us the least common denominator for the numerator? Mickey, would you like to give it a shot? Mickey, are you with us? Mickey?
I am, but I'm not sure.
Okay. Killan? Gabby? Gabriel?
Is it square root of x?
Mark?
We gotta multiply the bottom ones together. So
very good. Thank you very much. 1 plus the square root of x, 1 plus the square root of x plus h. They have nothing in common. They are two different factors. The least common denominator must be the product of the two. Great job. Thank you. I don't have to write thank you, but I have to write thank you. Okay, so then the numerator of the first fraction gets to be multiplied by what? The numerator of the second fraction gets to be multiplied by what?
So the numerator of the first fraction is going to be multiplied by 1 plus square root of x. And the second one's going to be multiplied by 1 plus the square root of x plus h.
Great job, thank you. Good, so 1 plus the square root of x minus 1 minus the square root of x plus h. Perfect. Obviously, we see that these two go away. And at this point, we will, how do we divide two fractions?
Multiply by the inverse.
Multiplicative inverse, very good. And what did we say a long time ago has to happen, that has to happen whenever we calculate the difference quotient?
We need 1h.
So all terms without h must go away. And h in the denominator has to go away. Now because we applied the limit, all h's will go away. Good, so then the numerator was the square root of x minus the square root of x plus h, and I'm going to just put this one in front next time. So again, when you plug in h approaches 0, you will get 0 over 0 guaranteed. So what do we do next? And this is exactly what we did a minute ago. That's the reason why I didn't want to repeat this, but it actually was a good pick, very good pick. So how do we continue? Anyone?